Your syllabus requires you to integrate by parts. It does not require you to know where that rule came from, but I'm going to show you where that rule came from. Substitution is the chain rule backwards. Parts is the product rule backwards. So, the derivative of uv is u dv dx plus v du dx. Right, that's the product rule. So what I'm going to do is rearrange it a little bit. How did they rearrange it? Yeah, okay. So that means, let's integrate both sides with respect to x. The integral of this side is just going to be uv, and I want the integral of u dv dx plus v du dx. Why do my u's keep going funny? With respect to x. Well, that's the integral of u dv dx plus the integral of v du dx. Do the two pieces separately. So, if I've got one integral, I'm going to get it, make sure it lines up the one they've got in the formula sheet. Yes, u dv dx. I want this one. It's going to be uv minus the integral of v du dx. And that's what your formula sheet says. Only it's got this on the right. What we're going to do is take an integral here and write an equivalent expression with a different integral. And the goal is the new integral should be easier than the first one. Our goal is to take something difficult and make it something a little bit easier. Now, your formula sheet says this, but there are other ways to write this. First of all, you could write this using the substitution. You'll often hear me saying this version as I'm writing it out. That's how I remember it. Integral of u dv is uv minus the integral of v du. You could also write this as uv minus integral of v u dashed dx, integral of u v dashed dx. They're just different ways of writing the same thing. Just remembering, we're going to start with this side and end up with this side. It was just an accident of the algebra the way I wrote it. You can do this whichever way you prefer. This is the way it appears on your formula sheet, but you can think of it, write it any of those ways. It's all the same. I tend actually to write this version, but say this version. Go figure. Let me give you some examples. Suppose I want the integral of x cos x dx. I want to take my x cos x and I want to treat, well, sorry, the first thing I should go is, it's a product. I must be starting with a product in here. And neither of these is the derivative of the other. If it was, substitution is going to be much quicker. If this was an x squared and this was an x, use substitution, it's going to be much quicker. It's not. I can't get derivatives out of this. So parts it is. I want to choose one of these to be u and one of them to be dv dx. Slightly different how you do the product rule. I'm going to go u equals v dashed equals. Which one I choose matters. I want to choose for this one something I can differentiate and make it simpler, and something for this one which I can integrate. The biggest problem is usually you pick something here you can't actually integrate, or it makes it even messier. Don't do that. The one I can differentiate and make simpler is x. And so this one's going to be over here. It's easy to integrate. So then we're going to go, maybe I'll use a different colour for that. That means u dashed is 1 and v is sine x. So this, in terms of my u and v, is integral of u v dashed dx, which means it's u v minus the integral of v u dashed dx. Just apply my integration by parts. Substitute. U times v x sine x minus the integral of v u dashed sine x dx. And look at that new integral, it's much simpler, it's easy to integrate. X sine x minus, no, now plus cos x plus constant. I'm going to treat one of these as u and the other as v dashed. This one's got a square root. It's going to be nasty whether I'm integrating or differentiating. But differentiating this is simple, so put this one first. X root, actually I'm going to write this differently. X plus 1 to the half. So this one is 1. Oh, I was doing that in green, wasn't I? U dashed is 1, and this one is x plus 1 to the 3 on 2 divided by 3 on 2. Is that clear enough? Do I need to rewrite that in blank so it's readable? 3 on 2. Raise it by 1, divide by the new power. Okay. So this is the integral of u v dashed dx, which is u v minus integral of v u dashed dx. And substitute. u v x, let's go 2/3 x plus 1 to the 3 on 2, integral of 2/3 x plus 1 to the 3 on 2. Still looks messy, but it's much easier than it was. It's no longer a product. You okay, Julia? As I've said before, integration by parts is reliable, it works, as long as you choose wisely, but it will take you a little bit longer. But we'll get there. I turned a complicated looking integral with a product in it into a... this integral looks scary, but it's much simpler. There's no product, there's no substitutions, it's very straightforward. 2/3 x plus 1 to the 3 on 2, minus 2/3 x plus 1 to the 5 on 2, divided by 5 on 2. Or 2/3 x plus 1, 3 on 2, minus 4/15 x plus 1 to the 5 on 2, plus constant. And if you had to, you could factorise some of this out. You factorise out 2/3 and x plus 1 to the 3 on 2. And this term you would just end up with x plus 1 left. You could if you had to. If all I'm doing is integrating, just stop, that's fine, I'm done.